Hey guys, so in this video, I'm gonna share one other common things, the problems that happen in Superset that will cause timeouts on the dashboard. So you can see here's an example of a dashboard that is timing out really badly. In the other video, I've already taught how you would optimize 100 million rows of table, from a 1.5 minutes, optimize it down to only 6 seconds load time. So that is on the SQL level, right? Now, what I'm going to teach you in this video is going to be application level, which is on the superset, the dashboard itself, on what you can do, what kind of superset features that you can leverage in order to prevent error like this. Okay, so I'm going to show one example here where the timeout doesn't happen and we are dealing with a lot of tables, and they are pretty large tables, right? So first thing first, okay? I'm going to show some, let me just scroll here. Okay. So one of the common things I love to do when dealing with large tables, okay, um, is to perform what I call server pagination. Okay, server pagination is something that is going to be really helpful because when your dashboard contains 1, 2, 3, 4, 5, 6, 7, 8 charts, okay, that's 8 separate requests running on the same time simultaneously to the backend to in order to load this on the front end, right, on the dashboard. Now, the problem is if we didn't do this pagination, what's going to happen is it's going to end up timing out because there's a lot of data to load here all at one go. And remember that Superset has a timeout limit, whether you set it on 60 seconds or 2 minutes and stuff like that. Okay, so in order to implement this, I would normally go here, and then what I would do is I would just apply server pagination here. So I would apply here, and then I would click 10. Okay, I would just make it, the lower the better. Okay, the lower the better. We will let the users browse through the pages themselves. Okay, so that's one optimization that I love to do, and you don't see that happening here basically. So now now you might notice that here in this table I'm showing a lot of different things here. Okay, now don't worry about this error. So this error is basically a Jinja error that normally comes because it's not there is no time range input here. So normally how you address this issue is just apply the time filter, because sometimes what's happening, and I noticed this bug sometimes happen in Superset, is that sometimes the time range disappears on its own. So all you need to do is just perform refresh. So perform a refresh. So you can see here upon refresh, there is no longer the error. Okay. So the back to the detail tab that I built here. Okay. So one of the requests from the client is to basically see all data, right? So in this patient level tab, they prefer things to be paginated. They're okay when I told them like we need to paginate it because there's a lot of data. Okay, so it will also break the UI if things just keep going down. So the alternative that I'm doing here for this, for example, here I have no choice but to expose the data rather than using the server pagination. But if you notice, what I did was instead of having to show all metrics, all tables in one dashboard, I purposely separated. So there's the main parent tab, and this is the child tab, right? The tool that inherit from this parent here. So you can see I did 1, 2, 3, 4, 5, 6, 7, 8 tabs. Okay, it represents one metric. So you can see here, this is also one really smart way to optimize the performance of your dashboard by creating these tabs, right? Which I find it really, really useful that they have this feature, because one thing that I noticed, when you start activating the Superset tab, it only sends one request at a time, only to the server, only upon the tab being clicked. When you initiate a click here, only then there's one request being sent to the backend. It will try to load the data a few seconds before showing it to the customers, to the client. Okay. Now that's one other way. Now another thing that I need to also emphasize when it comes to, I'm just gonna push it here, okay? Because we're gonna look at this left hand side here. Now, one of the things you need to remember is that Superset will always try to run multiple simultaneous requests all at one time, just to serve a dashboard to a particular user. Now, the only problem is, if you were having a really large data set, really large query that is going to have a lot of computational time. Now, imagine if you have the same data set, right, behind all charts, which I'm not a big fan of, because even though by right, so if you go here, right, one thing that you'll notice is I actually named the data set differently per chart. Okay. You can see here, this is only for HbA1c, okay, metric. And then, yep, so this is my internet line for sure, okay. So even if you go APOP here, okay, remember this error is because it's trying to load a time range, which it couldn't. I'll show you why later when I show you the settings of the filter. Okay, so okay, so if I were to go with, and bear in mind here, I'm also on a very poor internet line here as well, that is impacting the performance of this video demo that I'm showing you guys. I'm gonna push this away. Okay, there we go. Edit chart. So you can see that instead of using the same data set across all charts, you will notice that I'm using a very different data set per metric. Okay. Okay, so as you can see here, APOP v2. Okay, so it's very clear that I'm using different data set instead of loading all the stuff at one go. So what's going to happen is that if you use one data set across all charts, Superset is going to call that data set over and over again. Okay, it will call one time to display HbA1c, one time to APOP, one time to TRIG, one time to HSCRP. The problem with that is it's pressuring the load of this particular data set, which is, where you have all these different charts trying to request on one single data set. That is why I would normally separate metrics data set, right? I will separate it, for example, per metric type of data set. Okay, one data set for HbA1c, one data set for APOP, and stuff like that. So now, what you're gonna do is, I also do the same for filter as well. Okay, for filter, now you might be wondering, why do we keep having this error? Okay, again, one is I'm having a very poor internet line right now. So it's not loading properly. Okay, one other thing is that because I have a dependency, this thing has a dependency on the time range. Okay, if the time range is now not loaded, it will throw an error. It will try to load itself first before this is made available. That's why the error will appear. So one other thing I wanted to actually teach you guys is basically it is always best to separate filters, right, for data set, right? So especially when you have things like, let me put it this way, like full name, for example. Okay, full name, there's a lot of values that you want to capture from the full name columns in the data set. So what I would normally do, I would also separate dimensions as well and make it an own minified filter data set. Okay, So by using this technique, and remember, in order to implement this technique, you have to make sure that the data set of the filter that is containing the column name of full name must be the same as the chart data set, right? So if you're trying to filter the dimensions of full name in the filter data set, and then you want to make sure that it is mapping to the corresponding same name of column, same column name, which is called full name, or else it's going to fail, right? The data set is going to fail. So um, so basically what I'm doing here is that I want to disperse the requests across multiple data sets. You know, this is the same case when you're dealing with Kubernetes, for example. I'm just talking a little bit of backend here, where we built different, different nodes, different, um, containerized apps, for example, right? So they will make copies, Docker and Kubernetes will make that copies of containerized apps available everywhere. If the load spike, if let's say there is a load spike that requires 10,000 simultaneous requests, without crashing, then it will try to perform load balancing by creating these clones of different containerized apps in order to make sure that one app only received 100 requests at one time. So I'm using the same concept here. Imagine the data set is the container, right? I'm ensuring that no data set is being pressured with too many simultaneous calls at one go. Rather, I create different data sets, including the filters, in order to make the loading much more smoother. Okay, so I would separate the metrics into different data set, right? Including the filters as well. Okay, so that's pretty much sums up what I wanted to share about what I would normally do. So you can see here, there's no such thing as timeout error here, okay? And basically it's loading without timeout. So these are the stuff that I implemented on the superset level in order to make sure that the dashboard is working properly without timing out. And be sure to check my other video that I mentioned about how do you actually do SQL level, query level, or dataset level type of optimization, which can be applicable not only for Superset. If you're using Metabase, it will work as well. If you're using Tableau, Metabase, Power BI, it works the same. It just uses the same fundamentals of SQL, right? Then stay tuned for my other video where I'll be talking about how do you implement indexes or materialized views. This is on the server level. What kind of lakehouse engines would you use? What kind of AWS server settings that you would use that would be sufficient to run simultaneous calls on very large tables. I will definitely cover that on a separate video. Stay tuned for that video, and hopefully this helps. Take care.